A lot of stuff is currently happening in the IBM Power space, especially on the AI side. IBM Spire was just announced at the IBM Tech Exchange. What's Next.data will be enabled on Power, and there's so much more which is happening there. I will give you a hands-on guide today how to set up a RAG application on the IBM Power Server, and that RAG application is able to answer questions about the IBM Redbooks. RAG, or Retrieval-Augmented Generation, is a key workload on the IBM Power Server, and it enables companies to have internal chatbots on their specific data. The solution that I'm going to show you today is a chat assistant for IT operations, and this chatbot is basically enriched with data from the IBM Redbooks. The whole code for this project is open source. The link is in the description. You can access it. In the code repository, you also have a description of the steps that I'm going to perform today. And I will also show how you can set up this whole pipeline. So stay tuned. Before we get our hands dirty, I want to cover some theory aspects around the Power Server and also the RAG pipeline afterwards. The Power 10 server basically has a full stack optimization for AI workload. What does this actually mean? The Power Server in itself has hardware acceleration units. They're basically called MMA units or matrix math accelerators. They basically make the matrix multiplication more efficient, which is really important for AI workloads in general. Of course, the Power Server has other great properties like a high memory bandwidth, which is also really important for AI applications. On top of that, we provide through different channels optimized software components which are making use of the hardware acceleration that we have. For example, software like OpenBLAS or PyTorch, and of course the whole stack which sits on top of that. This diagram shows how a RAG application really works under the hood and what components are being used. With a RAG application, you can basically have an internal chatbot for your company without doing any training of a large language model or doing any fine-tuning. And this is also the sweet spot for the Power Server with also our upcoming new product, the IBM Spire accelerators. We are focusing on making inferencing of applications, for example, a large language model, as efficient as possible. So in a RAG application, a user asks a question, for example, does IBM Power support multi-compute arc in OpenShift? That question is given to a Q&A web interface, which could look like this. And afterwards, this question is sent to a vector database where a similarity search is done, and the chunks or the documents which are similar to that question are retrieved from the vector database. Once we obtain these documents which are relevant for the question that the user asks, we are giving these questions with the documents to a large language model. And we're doing all of that inside of the prompt. Therefore, we are not training or fine-tuning the model, but we're infusing data into the prompt that we're giving then to the large language model afterwards. The large language model which can be used can, for example, be an IBM Granite model. In my application, I'm using the newest IBM Granite model, the IBM Granite 4. Once we've given the prompt with the documents to the LLM, we can generate this domain-specific answer, which could look like, yes, IBM Power does support multi-compute architecture, and so on and so forth. All of these components which are necessary to set up a RAG application, for example, a vector database, an inference engine, a large language model, and so on and so forth, are all working on the IBM Power 10 server under a Linux LPAR. Of course, they're also working on the IBM Power 11 server. Okay, so let's demystify this vector database and how this vector database actually stores the documents that we have. So the whole pipeline to get from a PDF document, for example, to a vector database looks like that. So the first step really is to convert our PDF files into Markdown files. Markdown files are great because the computer can work with it. Think of tables, for example. In a PDF file, you have a table, but the computer cannot really work with it because it's weirdly formatted. So you need to convert the PDF into this raw text format, for example, Markdown. When you have the raw text format, then you actually need to chunk this into smaller pieces. And once you've done that, then you need to take every chunk that you have and convert it to a vector. And that vector is, for example, here 786 dimensions large. And that vector then, this presentation of numbers, can then be given to the vector database. So each vector in the vector database represents one chunk. All right, it's time to get our hands dirty. The whole code for the setup that I'm going to do today is open source, as I mentioned, and is documented in this GitHub repository. I will switch between the terminal and this GitHub repository just to show you that you basically just need to follow all of the steps which are outlined in here. Okay, so the first thing that we really need to do is install a bunch of libraries through DNF. For example, Vim, Git, different compilers like GCC, and so on and so forth. Second step is going to clone the GitHub repository, which is linked here. So let's do a git clone on the repository, and this will basically fetch all of the files that we have in there. Okay, let's check it out. We see here our rag public repository with different Python scripts. Okay, the next step is really to install Micromamba. I'm using Micromamba still, which is kind of the old way of doing stuff, but a lot of customers and business partners know Micromamba now pretty well. They're used to it, so I'm sticking with that. But if you want to see the future, then I highly would recommend the wheel ecosystem, which is out with the precompiled Power Wheels, also linked down in the description. So let's do a curl on Micromamba in our home directory, which is going to get the Micromamba version for PPC64LE, so for Power. And that's saved to bin Micromamba. So we now see here this bin folder, which has this Micromamba executable here. One thing that we need to do is to activate our shell with Micromamba, and we can do it like that. Eval, Micromamba shell, and so on and so forth. If you're doing stuff before you're doing that step, then Micromamba will also prompt you with an error message that you need to do that first. Okay, and now we can run Micromamba dash version. We are at 2.3.3. Do not worry if you're below that or if you're above that. Micromamba is pretty solid in the functionalities and all of that, so no worries there. Okay, so the next step is to create our environment. We can do that with the command Micromamba create -n, that's the name. Environment will be called reg_env, and we are doing that with Python 3.3. So let's do that, and that will take a couple of minutes. Good, so that's also done now. Now we can go ahead and activate this environment. So let's do a Micromamba activate reg_env, and you see that this will pop up here on the left-hand side. So if you see that, then you're on a pretty good way. Let's run Python version just to verify that we're running on Python 3.11. And you can also theoretically now list different packages that you have. We do not have so many packages because we did not install anything in that environment yet, but we will go ahead and do this in the next step. Okay, so we activated our environment, that's done. And now we will install the dependencies. We have two ways of installing dependencies. The first way is to use Rocket CE or the defaults channel, which provides optimized Python packages, for example, PyTorch for the power system, and so on and so forth. So we will install the packages from these two channels as far as we can. Okay, so we are installing all of the other packages from a different source. Why are we doing that? Because we cannot get a package like ChromaDB, so for the vector database, we cannot get that through Micromamba and Rocket CE. Let's just go ahead and do it as it's not working. So Micromamba install -c, that's the channel Rocket CE, ChromaDB. It will say, well, does not exist. That's why I'm using a gem theory. That's basically a privately hosted repository for wheels from a great colleague of me, Marvin Giesing. So shout out to you. And we can install that with the following command: pip install extra index. That's basically here pointing to the gem theory. And then we can install, for example, Streamlit, ChromaDB, Transformer, Sentence Transformer, and so on and so forth. Also docling. So let's do that. And this will again take a couple of minutes. Great. So now we have all of the Python packages in place to set up the whole RAG application on the Power Server. You see a bunch of different Python scripts in here. You see, for example, one script which is called admin_database.py. You see another one which is called converter_docling. You see one which is called Streamlit for the front end, and so on and so forth. You also see one folder which is called files for database. If you go in there, then you will see again different folders, and they basically contain pre-converted documents from PDF to Markdown. So they contain a bunch of PDF documents. So for example, in this folder, you will see a bunch of PDF documents about AIX. These are really just open source components from IBM, Redbooks about the E950, and so on and so forth. But you will also find a folder called db files md, and this contains Markdown files, so stuff which was already converted from PDF to Markdown, because normally this takes a couple of minutes. So let's take one file from that folder and put it into the test folder, because I do not want to convert all of these files now. That would take a lot of time. Therefore, let's just take one PDF file and, just for the sake of the moment, see how that works out. We have that file now in our test_PDF folder. Great. Now let's go into this Python script, converter_docling. In that Python script, you will find a bunch of stuff with which you can play around. You do not need to do it, but you can. For example, you can play around with these docling options. If you want to do a table analysis, if you want to do code enrichment, and so on and so forth. But the pipeline that I'm working with is really pretty basic, but as I said, docling already gives you pretty good results with that. So the only two parameters that you really need to change is here the source directory and the output directory. So I already did that, so that's a bit faster for this demonstration. So the source directory is files for database test_PDF, and the output directory is files for database test_md. If this folder is not present in the folder, then it will be automatically created. Let's go ahead and start the converter_docling script. You see that there are some logs outputted. You also see now that we are processing exactly that file that we wanted. And this will take, depending on the file of the size, longer or shorter. So if you have a really large PDF file, then it will take longer. If you have a small PDF file, then it will be shorter and faster. Okay, so that's already finished. That was really fast, 30 seconds, 1 minute, but that was really because that was the smallest file from all of the PDF files that we have in this project. But for the sake of this exercise, I think that's already great. So the next step is to basically start our chroma_db_md Python script. And you do not need to adjust anything in the script. It will do everything on the fly. So let's start it. And after a while, we are prompted with a path, as you can see here, that we should enter. We need to enter a folder or a file directly, but a folder is better, a folder which should be loaded into the vector database. But that folder needs to contain only Markdown files. And the folder that we are taking is here under home, CSC user, reg public, files for database, test_md. So it's basically the folder that we created. And second step, name the collection into which we are uploading that file. Let's call it AIX. So that's done. That was basically pretty fast. The reason for that is that the file is, again, not long, and you see that this worked out well. Let's talk now about inference engines. I'm using Ollama as an inference engine here. You could also use BLLM, Llama CPP as you like, as long as that inference engine provides an OpenAI compatible backend. That's really important, because then you can just run the inference engine, provide your models, and change the IP or even localhost inside of the scripts. I'm using an Ollama image from a colleague of mine from Anjil, and the team around him are working on a lot of performance stuff with these images. And with that image, with the version 3, you are able to pull Granite 4 and let that run. That's the reason why I'm using that. Okay, so let's run it. And of course, let's install Podman before that. Sudo dnf install Podman. Right, so that's done. Now let's do a Podman run with the right image. This will be pretty fast. These images are not too heavy and not too large. Once we have that, we should see that also with the command podman ps. You see now that we have this image here, which is running Ollama serve. We need to load a model into that image, and that's exactly the second command, podman exec -it, so we can get into the container, and then we are basically taking the binary and just pulling the Granite 4 double point tiny -h model. That model is also not that large, 4.2 gigabytes, but the great thing is it's a mixture of expert models, so the number of parameters that the model has is way larger compared to the active parameters. And these mixture of expert models really give you a great performance and a great answer quality. Okay, so now we can just test if we actually have these models inside of the container. So let's do a curl localhost port 11434/API/tags. And you will see here that we have indeed the Granite 4 tiny -h model. The next thing is basically to just run the application. So let's do this command streamlit run streamlit underscore advanced.py, pull it up here, then you will see the application that we have. You also have some nice functionality that you can save your conversation and summarize your conversation. As I said, that's really important in these IT operations on duty calls. All right, so let's ask a pretty basic question about the document that we just provided. So a pretty simple question could be, what is the cluster aware function? That's basically information which is contained in the document that we uploaded. So let's see how that works out. And you see here that the chatbot is saying the cluster aware function is part of the AIX operating system. It allows a cluster of AIX nodes to be created, and so on and so forth. Then it says what the key capabilities are, and so on. And you also see here the sources from which it obtained their answer. So these are really the chunks which are retrieved from the vector database and given to the LLM in order to answer the question. Let's try another thing. What is the IBM Power, or let's make it a bit harder. What is the E1050? Second question. And you will see that the chatbot prompts, I do not find any information about the E1050, the provided snippets related to IBM Power Systems, and so on and so forth. So it doesn't know anything about it, which makes sense because you see in these chunks, we do not find any information about the E1050. Therefore, we are going to upload a new document now to the vector database, and we're doing that on the fly. Let's open up the admin underscore database.py file. This is basically an admin interface to upload new documents, and we can see here now this beautiful and great looking UI. That's a joke. There needs to be some work done on that UI. So we see here that we have one collection about AIX. We can, in theory, delete that collection. We do not want to do that yet. And we can also say which documents are actually in that collection. And we see that we just have one document about the AIX version 7.2 in this collection, and this contains 94 chunks. Let's upload a new file, and this is really where I'm pasting in just a path to the Markdown file. In theory, you could also use a folder which contains multiple Markdown files, but I will just do one Markdown file to make it simple and to show you how the process works. Let's take a new collection now, which is called Power 10, and let's import it. And this will take, depending on the size of the file, longer or not as long. Okay, you see now that this file has been imported with a total of 399 chunks. So let's just check that out for the moment. You see that we have a new collection now called Power 10. In theory, you could also add this file to the same collection that we had before. Then you do not need to create a new collection, but this is really up to the user. Okay, so let's stop that and let's head over to our Streamlit front end, which we need to start again. Okay, so that front end is up again, and we see directly that we have a new collection, which is called Power 10. Now we can actually ask the question, what is the IBM Power E1050? And now the chatbot is able to generate an answer for that because these information are actually inside of the vector database now. And you see that it says now that the IBM E1050, IBM Power E1050 is a rack-mounted mid-range server powered by IBM Power 10 processors. You also see here the chunks from which it retrieved these information. All right, let's ask maybe a harder question. How many cores does the E1050 support? Okay, and you see here that the chatbot responds. According to chunk 1 of the document, the E1050 supports up to 96 processors, and so on and so forth. And you see here that the chunks are now also larger. And in chunk 1, we have that information that the E1050 supports 24 to 96 processor cores. Okay, so this is basically it. This is everything from setting up the demo to the theory beforehand to adding new documents and really being able to use this demo. So if you have any questions regarding the demo, can be technical, can be non-technical, please reach out to me. My contact details are in the description below. I'm really happy to help. And yeah, try out this demo, try it out with your own documents, see how well it works or how well it doesn't. And also, I mean, message me if stuff is working great, message me if stuff is not working. I really appreciate feedback in both directions. So thank you for listening. Thank you for watching this video. See you. Bye bye.